right, today we're going to look at some more angles within a circle. We're going to define inscribed angles and intercepted arcs, and then we're going to talk about theorems that encompass that. So an inscribed angle is an angle whose vertex is on the circle and whose sides are chords of the circle. So here, my inscribed angle is this angle right here. Its vertex is on the side, and then its sides are chords. So in this case, it's angle BAE. Okay. An intercepted arc is an arc with endpoints on the sides of the inscribed angle with all of its other points on the side of the angle. Okay, so this would be my inscribed arc. So BE, in this case, would be my inscribed arc. The inscribed angle is half of the intercepted arc. So how do I find the value of the variables? So angle A, and this is where it might help to use some colored pencils, is here. Its inscribed arc is here. So the measure of angle A is going to be half of 76, which is 38 degrees. So I better double check my math. You guys know me and arithmetic. Okay, so angle A is 38 degrees. Angle D, I'm going to jump to angle D, is here, and its inscribed arc is the semicircle. So the measure of angle D, a semicircle measures 180 degrees, is going to be half of 180 degrees, which is 90 degrees. So B is here, but we don't know what C is because it's going to be twice what that angle is. But we do know that A and D are 38 and 90, and this is a triangle. So 38 and 90 is 128. And so 180 minus 128 will give us the measure of angle B, which is negative 50, or is 52. And then arc C, if the measure of the angle is half the arc, then we're going to double that, and C is going to be 104 degrees. So now we have a theorem. If two inscribed angles of a circle intercept the same arc, then the arcs are congruent. So I've got angle G, it's right here. Okay, and then I've got angle H right here, and notice that they both go with that intercepted arc. Okay, so the measure of arc FI is going to be twice 52, so it's going to be 104. And then FHI is that red angle, and it's going to be the same as the other angle, angle FGI, and it's going to be then 52 degrees. An inscribed right angle just intercepts a semicircle, and like we did on the first example, okay, anytime we have an angle that intercepts a semicircle is going to be right. So these angles are right. Just another theorem, but it's kind of common sense if you know that if this is 180, half of that is 90 degrees. And another theorem, because I know how much you'd love to learn those. A quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. So if I have angles 1, 2, 3, and 4, the measure of angle 1 plus the measure of angle 4 is going to be 180 degrees. And the measure of angle 2 plus the measure of angle 3 will also be 180 degrees. So they're opposite each other in the quadrilateral. Okay. So let's find the value of these variables. So A and 75 are opposite. So I know that the measure of angle A plus 75 is going to be 180 degrees. So if I subtract, then the measure of angle A will be 105 degrees. Okay. And then B and 80 are opposite angles. So the measure of angle B plus 80 is 180. So if I subtract 80 from both sides, the measure of angle B is 100 degrees. All right, so now we have a theorem about tangents. Okay, so what is a tangent? A tangent is just a line outside of the circle that intersects the circle in one point. It's more formal. So it's a line outside the circle that intersects it in one point. Okay, or I say it just kisses it because it hits it and walks away. All right, so K is what we call our point of tangency. And it is basically the same theorem. So if it intersects it, the measure of each angle formed is 1/2 the measure of the intercepted arc. So if this intercepted arc is 126, this angle right here is going to be half of it, which is 63. And then you could figure out the other angle because 180 minus 63, they're on a straight line, is 117. And then you could actually figure out this other arc by doubling that to 234. So yet another example. We're combining things in here. So I've got this inscribed angle C, okay, and it intercepts this arc, which is 150, so the measure of that will be 75 degrees or half of 150. I know that this arc right here is 90 degrees, and remember that the total degrees around a circle is 360. So 360 minus 90 minus 150 will give me the measure of that arc. So it'll give me angle A, or arc A. So 360 minus 240 is 120. So A equals 120. And then B, because it intercepts that arc, got my tangent, and then it intercepts that arc, will be half that. So the measure of angle B will be 60 degrees, or half of that. So go ahead and pause the video and try to do this example on your own. And then I will go over the answer. Just pause it, do it on your own, and then we'll go over it. All right, so if that arc is 43 degrees, I don't think I would start. We know that, or this angle is 43 degrees. We know that that arc is 84. Okay. Angle B cuts off a semicircle, so we know it's a right angle. So B is 90 degrees. If you look at angle A, here, it cuts off that intercepted arc of 84 degrees, and it's going to be half of that, so A will be 43 degrees. And then D is with a semicircle, so if the arc that we know here is 84, B is going to be, or D, sorry, is going to be 180 minus 84, which is 96 degrees. And then C cuts off that arc, so half of 96 is 48. So C is 48 degrees. All right. So remember, we need to know the vocab, the inscribed angles, intercepted arc, and a tangent. Your theorems, if two angles in inscribed angles of a circle intercept the same arc, then they're congruent. A quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. And if a tangent and a chord intersected a point on the circle, then the measure of each angle formed is 1/2 the measure of the intercepted arc. So have a math-tastic day.